Okay, now we'll be seeing the second problem of today, the 900 rated one. Okay, so let's see what the problem says. A median of an array of n integers is n by 2th, rounding up the position of the median, and n and k are non-decreasing arrays of n times k integers. We need to divide all the n into k integers into k arrays of size n such that each number goes to one of the arrays, and we need to make it such that sum of all the medians of k arrays must be maximum. So let us state what we have just read. So the median, let me take the marker. So the median is n by 2th, rounding up element from the array in ordered in ascending order. Okay. Then n is the size of each array that we need to divide it into, and there are k such arrays. We need to make such divisions. And the constraint for such division is that we need to maximize the in sum of all the medians of the k arrays. Okay. So let us say that an array of n integers, right? So there are n integers. So there will be some integers to the left. We are sorting it in ascending order. Okay. There will be integers to the left, then there will be a median element, and then there will be elements to the right. So this is a structure of a particular array. And what we are concerned with is the median. We need to maximize the sum of all the medians. So the greedy way is that we need to maximize individual medians. So how can we do that? So as I said, this is the structure of each array. These are different number of arrays. Okay, so array 1, array 2, array 3, array 4, array 5 all have such structure that this at the starting there is a smaller number than medium, then there's the median, and then there's a greater number than the median. This is the structure, and we need to maximize each of the medians, each of the middle values. So how can we do that? So as we are concerned with the maximums of medians, where we can start is we'll first sort the given integers, the n times k integers, these many integers in ascending order, right? So once we arrange them in ascending order, then we can put them into the array such that the constraint is valid. So one way we can do is that we'll start filling up as we for a array, for a maximum for a maximum median we need numbers that are greater than the median itself, right? We need numbers that are greater than the median. So we need numbers here, then there will be a median number. We need some numbers greater than the median here, then the median comes. So what we'll do is, from all the integers, let's say there are a1, a2, a3, a4, a5, these all are arranged in ascending order, right? So what we'll do is we'll first fill the number from the numbers that are the greater numbers from the end in the this region, the greater than median region, and also the median. Like a5, let's say the size of the array is 5. Okay, this has an array. This is an array of size 5. So there are two elements here, the median element and then again two elements. Let me switch the color. So two elements, the median element and another two elements. So to maximize this array, the median of this array, what we can do is we'll start filling up the greatest values. So how we'll do this? So the greatest value will go here, a5. So the greatest value will go here, A5, then A4, then A3, then A2, then A1. So this is how we constructed an median array with the median as the greatest of all. Okay, this is how the approach is, that from all the integers we first need to fill this. Then again, okay, this was for the first array. Now let's say there are even more numbers, right? Let's say there are numbers. Let me erase this. Let's say there is number A7, A8, A9, A10, A11, A12. Okay, like this. And this is also in the ascending order, right? Just I have the numbering is very arbitrary, but just consider this is the ascending order. As we go from left to right, the value goes on increasing. So what we have done is we filled all the starting five integers in the first array. But is this the optimal way? No, it is not. This is not the optimal way. What we need to do is, these are the numbers, right? Wait, let me write it for you clearly, okay? There's too much confusion there. A1, A2, A3, A4, A5, A6, A9, A10, A11, A12. So what we'll do is we need to construct arrays of size 5. So we'll add some more numbers. Wait, 13, A14 and A15. So we have numbers till 15, and we need to construct arrays of size 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There will be total 3 arrays of each of size 5. This is, let's say, the question, arbitrary question we have assumed. So we need to maximize the medians. Where is the median? The median is here, the median is here, and the median is here. This is the position. We need to maximize this m1 plus m2 plus m3. So m1 plus m2 plus m3 should be maximum. So for this, individually m1 should be maximum, individually m2 should be maximum, individually m3 should be maximum. So what we'll do, as I have stated that this is in ascending order, so as we go left to right, the value increases. So we'll start filling it up. So let's fill it up. How can we fill it up such that it becomes maximum? The A15 comes here, A14 comes here, because we need a greater value. Here we need greater value than the median. So the greatest value first we put it here. Then the next value A13 comes here. A13. So now what I did earlier was I put A12 and A11 here, right? I continued with this. And what is this region? This is the region where there are numbers lesser than the median, right? But is this the most optimal way? No, because as we need a maximum numbers here, the greater numbers, the value which is greater, we need those for this region and medians. Therefore, we need to use all the greater numbers for this region first, because this is where the constraint is. Here, the area where there are lesser numbers, there is no constraint. We just need to make it such that these are lesser than the median ones. And if we choose from here, that is the least minimum values, then that holds true, right? So instead, what I'm saying is, instead of putting A12 and A11 here, like A12 and A11, we need that A12 and A11 as these are greater numbers. The value, they have greater value. So we need these numbers here in this region. So we'll put A12 here, A11 here, then A10 here. Similarly, the next numbers will start filling from here, A9, A8, A7. And now the rest, which are all the least values, you can directly put them here. There's no need to check the sequence of them. It can be anywhere. So what did this do? This did that. So our A13, let me change the opacity. Our A13 value, then A10 value. and then A7 value. These values became the median. Can you see there's a regular interval because we are filling it in a pattern, right? We are filling it in a pattern. So the medians will follow a pattern, and as we are filling it from greatest value to least value, that is in descending order, this will be how the medians will be selected. So that's the answer for the problem. So for any array, we'll just fill it up like this and we'll find the pattern which the median follows and we'll find these values like a third. What does this pattern depend on? This pattern depends on first the number of values here. So what is this? This is basically the size of an array, right? Depending on how long the array is, this pattern is changed. So k, oh, sorry, n. It was n, right? Yes. N, it depends on n. The jump in this pattern depends on n. If n is greater, then the jump will be greater because there will be a lot more elements we need to fill in, right? So that was it. And how many jumps? You can see that as we need, there are three arrays, we need three mediums. So there will be three jumps. I mean three values, two jumps, right? Two jumps and three values. So k, the number of arrays decides how many medians we get. That is also decides the number of jumps. So that was the solution. Now we need to find the pattern new mathematically. So I said that it depends on n. The jump depends on n. Let's consider this array, right? This array. So according to this array, the medians will be the medians will be. So this is how the structure of an array will be. The first element n is equal to 4, right? So the median will be n by 2th element. That is the second element. So the second element, the first second element will be the median. But what is we are starting from the right? The greatest value we fill the greatest value at the end here, then the second greatest here. So we start from the end. So we start from the end. So from the end, the value is n by 2 plus 1, right? The median from the start is n by 2th if it is even. This case is for even, right? So I have considered even and n equals to 4 as a example. So for even, from start it will be n by 2th. The position of the median will be n by 2th, and from the end, like from here, it will be third position, like 1, 2, 3, the third position. So the jump will be of three distance. So 1, 2, 3, we find a median. Then again, we start filling the second array. Like 1, 2, 3, we found a median. Then we start filling the next array. 1, 2, 3. So the median to median jump is also 3. Like once we find the median, then it will be 1, 2, and 3. Third value will be median. So in here, the first element, second element, third value is the median. The third value is the median. Then we'll again start jumping. So jumping will be 1, 2, 3. The third array, the third element will be the median. Got it? So likewise, 1, 2, 3. The third value will be the one. But that's it. Okay, look here. There were two elements. Okay, two arrays. Array number 1, array number 2. But in this pattern, we got three elements. We did not because there can only be two medians, right? So this will be the median 1, this will be the median 2, and done. If we stop here, then all the remaining values we start filling in the lesser area. Okay, let me show you. So the 14 will be here. Let me change the font. 14 will come here, 13 will come here, 12 will come here, then 11, 10, 9. And then the remaining okay, I have taken an extra value, it seems. 14, 13, 12, yeah, right. This is not here. So 10, 9, and 8, 7. This 8, 7 we can fill anywhere, okay, this doesn't matter. Only the arrangement of this area matters. The one where the numbers are greater than the median and the median. And for the odd case, right? When the n is odd, let's say these are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the n is 4. The size of an array, sorry, 5. The size of an array is 5. So here the median will be n by 2th from the start, which is 2.5. If it is integer, then it will directly come as 2. But we need to round it up, right? So 2.5 rounds up to 3. So n by 2th plus 1, okay, from the start. Sorry, n by 1 plus 2th, okay. We need the third value, right? So it will be n plus 1 by 2. So it comes to 3. So it will be the third value from the beginning, and as it is odd, it will also be the third value from the end, right? As this is symmetrical. The third value from the beginning is the third value from the right. So the median, when we start filling the values like 10, 9, 8, so 8 becomes a median. Just a second. 8 becomes a median. After that, 8, 7, 7, 6, 5. 5 becomes a median. After that, we need to fill all the other values here. 1, 2, 3, 4 doesn't matter. 1, it's like 1, 2, 3, 4. This doesn't matter. So we jumped from the jump is of value n by 2 plus 1, that is 3. You can see here from median to 1 to 3. The next medium is at a distance 3 from the initial medium. So the jumps are of 3, and also from the starting it is the third value. From the end it is the third value. The first median, in this case the 8, is the third value from the end, right? 1, 2, 3. It is the third value. It is the third value. So we just need to write it mathematically that uh, let me show you with the test case, right? Have I explained everything else? Yes, I have. Where's the question? Okay. So in this case, you can see that n is equal to 3, right? N equals to 3, which is odd. So it will be n plus 1 by 2. The jump will be of n plus 1 by 2. That is 4 by 2, that is 2. So the second element from the beginning, and the jumps will be of 2 units. So this is the case we are considering, right? N is 3, K is 4, and this is the array. So the second position, the first position, the second, median 1 will be 94. After that, a jump of 2 units from the median 1, 1, 2. This will be the next median. Median 2 is equal to 16, sorry, 71. No, sorry, 69. I was right. 69. Then median 3 will be 38. Median 4 will be 33. Median 5 will be 12. And as let's see here, the check is the pattern is there, but we also need to check the number of medians we are finding out, right? Because the pattern is an arbitrary pattern we have found. As there are three arrays, there will be three medians. So this two values from the pattern do not mean anything. Okay. So these are the three values. Why where is that? Okay. So these are the three median values which you have found using the pattern, because there are three number of arrays. Sorry, this number of arrays is four. Pardon me, I'm getting it all wrong. There are n is equal to 3, that means the size of the array is 3 and the number of arrays is 4. So there will be 4 median. The next median will be 33. Yeah, okay, now this is correct. So these are the 4 medians we have found using the pattern. There will not be another fifth median. Yes. Okay, so this was the solution. I'll show you the code. The indicing matters a lot. Okay, you need to focus on the indicing here. I have sorted the array. It was already sorted, so there was no need of this. Okay, then the jump. I'm stating how long the jump will be. Jump depends on the size of the array. If it is even, the jump will be of size n by 2 plus 1. As the median is the n by 2th element from the beginning and n by 2th plus 1 from the end, and we're starting from the end, the jumping pattern is from the end, so n by 2 plus 1. Okay, and if it is odd, then directly it is symmetrical, so n plus 1 by 2. This will be the jumping pattern, and the sum of the medians we have initialized it to 0, and then I start. Okay, now this statement. Okay, I've started in this question. Let's say there are a1, a2, a3, a4, like that, a of n times of k, right? So indicing here will be 0, 1, 2, and here similarly n times k plus 1, sorry, minus 1, right? Indicing is this, and we need to find, like in this case, like in this case, this was the first, let me show you. Okay, so in this case, this was the median, this was the median, then this was the median, then this was the median, then this was the median, right? Four medians. So what I'm doing is I'm initializing the indice at n times of k. This is of indice n times of k minus 1. So this position, next position, I'm just assuming, okay, because you'll see the pattern. N times of k, and from here I'll jump first, and then I'll find the first medium. Then I'll again jump. Then I'll again jump. Okay, I assumed an indice which is not present because the jump is starting from there, right? So that's why I started from n times of k. So n times of k minus the jump. This was the first medium. Then the this position minus the jump. So that's what I've done here. That n times of k minus jump is the first position of the medium. I have added it, and then later on I just uh, subtracted the jump for the position. And for how long we need to do this? Till then we have the same number of medians as the number of arrays. The number of arrays was k, so till k is greater than 0 and k minus 1. This is the condition we need to follow, right? Okay, that's it. Thank you.